This video will cover number 15 on the Chapter 5 test review. In this proof, I've created a 2-column proof because I didn't have one drawn. If you already have one, that's great. If not, make sure you go ahead and put one in on your paper. We are given some information, and we are trying to prove that line segment AC is congruent to line segment DC. Where are those two segments? Well, one is here in the top triangle, and one is here in the bottom triangle. Before we can prove these two segments are congruent, because we don't have enough information yet to know if they are or not, we first need to try to prove that the triangles are congruent. So that's what we're going to set out to do first. Once we prove the triangles are congruent, we can finish our proof by stating that these segments are congruent. So let's start with our first given. We are told that line segment AB is parallel to line segment DE. Let's go ahead and work with that and see how that helps us. So here's line segment AB. I'm going to extend it. And here's line segment DE. Remember, parallel lines, they help us find pairs of congruent angles. We're going to be looking for a pair of alternate interior angles on these parallel lines. Now I've got a couple transversals that cut through. So I want to look at both of those. First, I'm going to look at this transversal that cuts through my parallel lines and notice if I see any alternate interior angles. I do have an angle that's formed here in this triangle from this parallel line in the transversal. Its alternate interior angle pair, if I go the opposite side of the transversal, would be here. These two angles are congruent. I need to add that to my proof. Angle B in my top triangle is congruent to angle E. And I could use just one letter to name those angles because there is only one angle at each of those points. I knew that these two angles were congruent because they were alternate interior angles. And alternate interior angles we know are congruent when lines are parallel. This helped us get one pair of congruent angles. Let's look at this transversal now because we have this transversal that also cuts through the parallel lines. We want to see if we can find any alternate interior angles on that transversal. There is an angle formed here from the parallel line in the transversal. Its alternate interior angle pair would be here. So again, these two angles are congruent because they are alternate interior angles on parallel lines. Let's go ahead and add that in our proof. Angle A is congruent to angle D because they are alternate interior angles. That allows us to get a second pair of congruent angles. Now be careful. Some of you might have, when you were doing this problem, you might have found these angles here that were congruent, and that's fine. They are congruent because they are vertical angles. If you did that and you put that in your proof, that's great. However, I can't use these three angles alone to try to prove the triangles are congruent. There is no angle, angle, angle theorem. So if you found these vertical angles, you can use them, but we can't just use these three angles alone. We also have one more given to think about, and so I'm going to go ahead and put this given in my proof. Line segment AD bisects line segment BE. Let's think about what that means. So line segment AD is here. It bisects line segment BE. Here's line segment BE. If AD bisects this line segment, it cuts it in half. it cuts it into two equal pieces. So line segment BE, it is being divided into two equal parts. So what this tells me is line segment EC must have the same length or be congruent to line segment BC. I need to put that in my proof. Line segment BC must be congruent to line segment EC. And that's by the definition of a segment bisector. AD bisected this line segment, and that's how I knew the two pieces were congruent. And so looking at my picture, that helps me get a pair of congruent sides. So for my proof, remember, I did not use the vertical angles. Maybe you did. If you did, you would be looking at these vertical angles to try to figure out which theorem you're going to use. But I am not, because I found these pairs of angles that were congruent and this side. So you need to use the angles and the sides that you put in your proof. Okay, so I am not going to use the vertical angles because I did not put those in my proof. So using the two angles and the side that I found were congruent in my proof, I need to figure out which of these five is being shown here. So looking at this triangle, I have an angle and an angle, and the side is outside the two angles. So in my picture, I have an angle side congruence theorem. So I am now ready to state that the two triangles are congruent. Triangle ABC is congruent to, make sure you match up your letters correctly, triangle DEC by the angle side theorem. And then finally, remember, we proved that the triangles are congruent, so we are now ready to prove our final statement, that line segment AC must be congruent to line segment DC. And we know that because corresponding parts of congruent triangles must be congruent.